Hello. Okay, welcome to the 7th class of Big Data Analytics. Today is the class before the midterm. So next week will be our midterm. Today, there are two things that we should be able to do. The first thing is I intend to actually go over the entire material, except in a sort of like step-by-step linearized fashion from beginning to end, and that would take us up to last week's material, which is the whole of unsupervised learning. Okay. Today we might be able to begin on unsupervised learning a little bit. It's the second part. However, it's not going. I'm not going to include supervised learning just yet into the midterm exam. Okay. Now, I'm really against the idea of telling students, sort of like the coverage of the exam. In fact, I make the habit that every time a student asks me, what's going to be on the exam, I deduct point from class participation. I consider that very not constructive. However, in this case, I think it might help to focus your I guess allocation of time and effort a little bit. So I might give you a guideline. Well, basically, you can expect that about maybe say 40-ish% would be on conceptual understanding. So you would have to give your response, I guess, in English, I guess, in language, with a little bit of mathematics, maybe. Okay, so explaining the concept of what it is that we are trying to do and why it's relevant and why and when you would use this kind of techniques and that, so forth. So these are the conceptual understanding. About maybe 40-ish% would be around your understanding of how to turn this into programming syntax or programming language. Unfortunately, that also means that you have to be pretty in order for the answer to work, you have to be pretty detailed and precise, so that even though you have the right concept, but your syntax is wrong, it's not going to give you the result, right? So if you don't have the right number of brackets, unfortunately, but that's real life, right? In real life, if you don't have the right number of bracket, it doesn't matter how brilliant your ideas in your head is. If your brackets don't match, you don't get the right results and it becomes worthless. So this kind of attention to details is actually a real lesson in life that you have to bear with. Okay, so being syntactically correct, that's part of the training. And about maybe 20-ish% would be focus on your own ideation of your project. So would ask a little bit about your project, what you're thinking about doing, what's your formulation, what's your data source, how you have visualized your data source, what have you observed, have you done maybe normality tests, have you observed that it's multiple cluster, that sort of thing. So it's very specific. So the last part obviously will be different for every person. In fact, the exam is going to be given in a notebook form. What's going to happen is, you guys know your own ID, right? So let's say this is at the beginning of exam, there'll be something like this: seed, random. Oh, sorry. Thought I'd share. Sorry. Share screen, share screen. Share. Okay. So so in the beginning of your exam, you'll be asked to put in your own ID. So let's say your student ID is, I think 53 something, 53, whatever. I don't care. Okay. Once you did that, you actually have a different randomized seed. so that in the sort of like a programming part, if there's going to be some kind of generated data that you would have to do some analysis on, obviously it would be very different from one person to the next. And the distribution, may be different. Maybe some of you may be given so it's like multinomial. Some of you will be given sort of like a maybe beta distribution to play with or something. Okay. So in the beginning, so you have to put in your name and then put in your ID. Okay. By the way, this is just to say state hash to identify. Okay. Right. Okay. Now, first, let me. I might as well give you a little bit of a background to this course, a little bit, just 2 minutes on this. Right. The way I envision this course, it's supposed to mirror the integrated philosophy of bite-sized education. Okay, what it means is that if you trying to learn any subject, any new subject, and this is what you guys have been used to all your life up to this point. In the beginning of the class, you'll be given some kind of textbook. Right? You'll be given some kind of textbook, and that textbook has chapter 1, 2 to all the way to the end. At most, that will happen is some of the chapter will be skipped. Okay, but it's very linearized. Okay, you go from the beginning to end, and that's it, right? With data analytics, I'm actually writing a textbook that does this. But the way I really wanted, the way I designed the course from the beginning was slightly a little bit more challenging than this. I meant to have, okay, so this is one theme. Okay, this is like maybe probability and statistics. This is something like in learning. And maybe this is some kind of interactive visualization. And the idea is that through your project learning, you kind of like jump back and forth a little bit between different disciplines. Okay. And that's the flavor I wanted you guys to get used to, because this is how you will have a lifelong learning experience with this. When you graduate, actually, when you finish high school, you were supposed to stop learning from one textbook. Okay. So anything you learn at all, even if there's one single topic, you shouldn't really, unless it's something like advanced mathematics, where really you can't really put things together, because mathematics is very axiomatic. You go from one to the next, otherwise things are out of order. But everything else, social science, data science, even physical science, there's some degree of skipping back and forth here and there. Okay. With physical science, less so. With mathematics, certainly not. But with data science, there's a lot of that. So get used to it. Okay, so get used to that. But having said that, again, for undergraduate, I'm going to try to sort of like put bits and pieces of here and there into a linearized narrative. And that's the sort of thing that you will follow from this, early version preprint of the textbook. Now, so what have we covered so far? This is the review. First of all, if you remember back last month, I guess, what's the first class all about? The first class is all about data science and data analytics. And a lot of it is realigning your expectation of what data science and data analytics is, because you guys have been watching, I don't know, YouTubes and whatnot, and you kind of think that this is what data science and data analytics is. So the good place to, again, and this is for, you know, maybe about 40-ish% of the midterm, maybe a little bit less, is to go to the mind map that I have prepared for you guys. And that's this one, right? You have that. Okay. Now, let me collapse everything and just you can see this, right? Okay. So let's collapse this, collapse this, collapse this. Okay, that's what we got. Oops. Right. Okay. So if you follow this thread here, this big tree here, that would take you into the sort of like spanning tree that describe the different techniques that could or may not be covered in this class that involve machine learning. Okay, there's this big chunk here that covers the topic that spans a topic that we may cover, or that you may have covered or not covered in your freshman year statistics class. But hopefully, if you've done a good job of that in your first year, a lot of the topic that when you click down here will be a reminder, as opposed to something, wow, I haven't seen before, right? So this should be a little bit of a reminder of the topic. Now, again, this class is about what? Data analytics, and the three pillars of data analytics that I mentioned is interactive visualization, probability modeling or statistical methods, right? And sort of like machine learning based machine learning algorithm and so forth. Now, because you've done hopefully a full year or half a year of probability and modeling and statistical inference, we are not spending a lot of time on that at all, okay? With machine learning, even though this class is not about machine learning, we will be using them as tools. But I don't want you to blindly use them as tool as if you were like buying a car and just buying different brand. Okay, I want you to understand why different brands matter. Okay, because a k-means brand of clustering analysis works differently from a dbScan brand of clustering analysis. So you have to understand how it works under the hood. That's my intention. Having said that, it's not about detailed algorithm because it's not a machine learning class. So like with last time, I give you a little bit of, I guess, hand drawing, sort of like how algorithm work. You know, you asked about t-SNE, for example. I would say, well, we have a little bit of a Gaussian tent over each data point and then project it into a lower dimensional space and try to spread them around using the t-distribution function, something like that, right? In that discussion, I didn't, bring the formula for t-distribution, but it's in there. It's in there. If you are learning machine learning, or if you're the programmer of the algorithm, you would have had to go into the mathematical function and program it, right? But in this class, you don't. You're kind of like a user of the tool. But you have to understand how different tools work differently. So you would understand which tools to pick. The interactive visualization is not in here, but it's really part of the introduction to Mathematica and programming and so forth. But what I want you to do as a review, okay, is go through this this introduction that actually goes into the definition of data analysis. All right, what does it mean? Why are you doing all this? So this basically, I would say maybe not quite 40%, but a big chunk of the midterm is hidden in here. Now, this is when you go through this, you have to understand, for example, okay, just click something random. This is a way of testing your understanding. Clicking something at random. Okay, clicking something random. Let's say I click this heat map or whatever. Okay, what does it do? Okay, why is it part of data visualization, and what kind of visualization? Now, maybe heat map, we didn't talk about it very much, but we certainly talk about scatter plot, right? The list plot. We actually saw this scatter plot of the old faithful, right? The waiting time versus the shooting, the water spout flowing time. We saw this 100 times, right? So how does that do it? It gives a raw presentation of the data itself, right? There's no filtering. There's just raw data in however dimension there is. And of course, there's a limitation that scatter plot really only works in 2 or maybe at most 3 dimension. Okay. So all this, okay. And you can bet, because this is kind of like pet peeves area of mine, you can bet there's going to be some question about your understanding of the scale, right? Scale of numbers. So you have to be able to say, well, this is why is it a ordinal scale? Why is it a rational scale? Why is it a ratio interval scale, and so forth? Okay, this is very simple, easy stuff, but it's very easy for you to skip this kind of awareness and make more conclusion. Okay, the classic case is the data is ordinal, but you make, sorry, the data is nominal, but you make ordinal conclusion. Okay. And that doesn't sound like a big deal, but that's actually where the biggest data science sin is committed. Okay. When you're answering more insight, you're imposing more structure, more meaning than the data allows. Okay. So data science is about getting reality, picture of reality, insight into reality from your data evidence. If you're actually implying more than the data evidence gives you, that is a sin. Okay, that's not a technical error. It's a sin. It's considered that, right? Okay, so again, all this. So this is about understanding, you know, how you would what it means to get insight from data, and you might go back to the YouTube and review the video and how I reference the fact that really it's about modeling capability, right? Data is about it. The reason data matters is because data allows you to calibrate or parameterize your model, and model is what allows you to make better decisions. It's what allows human beings to make better decisions than other primates. It's what allows one company to make better decisions than another company, so forth, right? So go into that. So, and the concept of you know, this kind of analysis, you want to understand the data, you know, where they are in distributional view, or do you want to understand functional view in the sense of a mathematical mapping? If you knew X, can you tell Y? And if you knew X and Y pairing from the past, can you tell X and Y pairing in the future if you're given a new X, and so forth? So that would be the, but you know, it's kind of like descriptive, and I spend good half an hour or whatever now on each of those. So I'm not going to cover that too much today, even though it is a big part of the what you're going to be tested on. Okay. So let me just go ahead and go to the more technical hands-on. And right. Again, so this is my draft version of a interactive textbook. So it's got functionalities in here, and keep you revising. So I this thing I haven't expanded too much because I actually have sort of like an in-depth explanation of the conceptual understanding, you know, in the lecture I gave you in the first class, and also in another form. So it's not much in here, but definitely from chapter 2 on is something that you should be able to go line by line and be able to, I guess, replicate in the exam setting. Okay. Now, the primitives. Okay, the primitives. We talk about this idea that Mathematica, even though I haven't written here, but what I mean is that Mathematica 1.0 is really analytical computation. It was created by physicists for physicists, not for anybody else, right? It's the idea that you can actually understand symbolic interpretation of y is equal to x squared as opposed to numerical representation of y equal to x squared. It's supposed to understand equation that represent, I don't know, Maxwell's electromagnetics in abstract form. Like this is a divergent, this is a co-operator, that sort of thing, So really for physicists, by the time it gets to Mathematica 13, then you have many things growing around. So it becomes sort of like a basic functional programming paradigm that does anything and everything you wanted to do. So functional programming in a basic sense, a bit like, Python or R or something like that. I did mention briefly, although you're not expected to appreciate this, that Mathematica doesn't really follow object-oriented programming very well. That's object-oriented programming is something that I may have mentioned. It's actually central to my thesis, but Mathematica can implement that, but not in a natural way. So nobody does this in Mathematica. But mostly functional programming and a more higher level like declarative. So the layer of difference is that declarative is you tell the computer what you want it to do, okay? Whereas functional programming is you structure your communication with the computer in terms of functional call. So if you want the computer to do something, you call a function. I want you to do f to x to give me y. If you want to tell the computer to have a new capability, new algorithm, new capability, then it's your job to program in the f, the function. And that function in turn draws on built-in function. Okay, so that's what functional programming is. And so Mathematica has become that really very powerful. And because some of the functions are so ubiquitous, it's so normal. People want to do this all the time. In successive version, they keep encapsulating in a higher and higher level. So now instead of building a neural network to predict from A to B, you just say, well, give me a predictor. Okay, because people do this thing all the time. So it becomes a high level. And that is to be honest, it's a double-edged sword. It certainly is good for you guys, the half of you or 3/4 or 2/3 of you who are not going to data applied digital intelligence, to say, okay, I'm working with something on sustainability data. I'm working on something on the healthcare system. I just want to make a quick model that regress y upon x, and I don't want to really go into the nitty-gritty. So give me a rough regression between x and y. So it's very good. And for people who are going in depth, like me, people who are doing this professionally, it's also very good to give a sort of like a first shot stab at the problem, but that's not going to be good enough for a really challenging problem. And when we got to supervised learning, I have really good classical situation where I can show you why this kind of like just take a quick stab, build a supervised neural network doesn't really work. You have to do more work. So it's not a high level, yes, but it's not going to be able to do everything. Otherwise, then we wouldn't have professional data scientists, wouldn't have that. Okay, so, and then of course, with physics, the visualization is a big deal. So out of that kind of visualization of physical function, dynamical system, vector field and whatnot, now we get to the age of data science. So Mathematica has evolved around visualization of data set and all kinds of things, and this kind of big data, like visualizing non-numerical data, visualizing graph. We'll talk about, we haven't talked about that very much, but visualizing geography, like country data, all kinds of stuff. Okay. So, and finally, there's sort of like a platform that kind of grew alongside, which is the Wolfram Alpha, which is kind of like Wikipedia with calculation. So instead of just finding general information in a static sense, you find information, but then you get a data set that has some plot, some function, and so forth, and that. Right. And then we talk about, that there's like a platform I haven't talked too much about this, but certainly by asking you to look at demonstration, you can see that there's like a community. It's not a big community. It's not like a Python community or R community or JavaScript community. That's huge by numbers. That's a lot, okay? Because basically everybody. But so you have a smaller community, but they're pretty active, and you can do certain things. Oh, I didn't show you this. I think in the beginning of the class, you can actually. This is something fun for you. I might as well on. What you do is, I've taught you to do how to do the manipulate, right? All this manipulation, and you can do that to show. And I said this is a very good tool for demonstrating your concept, your idea, your drawings, whatever, and then interactively display. But I forgot to tell you that one of the neat tricks is that you can actually cloud deploy this, so that let's say instead of taking your mathematical program with you and demonstrating to your client or go to your cloud account, what you can do is just cloud deploy it and make a result public. And when you did this, let's say when you did this, what you're going to do is get a sort of like URL address. And when you click on that, this becomes a public domain anybody can play with. So imagine you like making a sales pitch. So I want to sell. I just make this hopefully kind of like nothing serious. Okay. So this is an app to pick your color. What's your lucky color today? Let's pick a green color. What's your lucky green? And or what's your lucky blue or whatever. So this is kind of randomized, right? So the idea is that, well, this is very simple program. Yeah. Yes. Now, it's free, but it's one of those things where I think it's free because you have the license and you have the access, right? Yeah. So it's free, but you have to log in. Now, I think that there's like a limit on how many you can have, and also maybe how long. So if you bought like it's like buying cloud space. If you have a cloud space, it's permanent. If you got a temporary cloud space, maybe they'll store it for a year, and after that you delete. But that's good enough, if by then you just keep having new idea. So when I deploy this, maybe in a year time, this would not work. But certainly I can show it to my client. Oh, I'm developing a widget here that allows you to whatever, picks a nice color, that sort of thing. So this would be cloud deployed. So this is public, and it's very friendly way of getting your idea to the. Okay. Now, so this is so go through this. These are all the primitives. Now you'll be tested on a little bit of this. In particular, what I want you to pay attention to, but this is kind of like output and recall. This is when you make an output, you want to refer to the previous. That's not that important. So maybe okay. But assignment and recall, that's certainly a very big thing, right? It's about you can't do anything unless you have, again, a functional representation. And what does a function understand? It understands input and output. And how do you have to have a name to input and output. You can't say do this to that. You have to name that. And this, you have to name the name of this function. So this becomes a name. That is a name. So you call this open bracket, that open bracket. And that's your result. And then you start somewhere, you keep. So this kind of assignment and recall and global scope. So, you might want to take a little side note by yourself. I could, but I think that's a little bit patronizing. You should be able to just pick from my voice what I emphasis I put on. But certainly this kind of scoping. Now, one thing that helps manage the scope, which is very useful, is module. So look into that. That's a big deal, because what it does is to say, I'm going to be working with X, Y, Z, but I don't want X, Y, Z to be prevalent everywhere. Okay, so I want to be local, so I put it inside a module. So module is a good tool to use. It's a very good discipline. So you should be able to do that. I guess on exam. I'm not gonna say anymore that this. If I say it today, then chances are it's important. Okay. Right. Now, what's the most basic data structure? Things, instead of saying X is equal to 5, X can be equal to many things at once. So that's what That's the concept of list, right? And list is such a fundamental object. Okay, it's fundamental object. I tell you why it's fundamental object, because you can have 1, you can have 2, and you can have infinity. Okay, what do I mean by that? In life, you can either have 1 or nothing, or you can have more than 1. And once you have more than 1, then you can start, once you can go from 1 to 2, you can go from 2 to 3 to 4 and so forth. Well, list is a bit like that, right? Instead of dealing with 1 number, now you can deal with more than 1 number. Not only can you deal with more than 1 number, you can deal with more than 1 type, right? So the first element of a list can be a number, 7. Second element of a list can be a picture. Third element of a list can be a color, right? So once you generalize the storage, that you don't have to have just 1 number anymore, you can have a whole bunch of them. It becomes like a data structure. So that's why list is like the data structure number 1, okay? And this is going to be true regardless of what language you are. I mean, it even cuts across object-oriented programming. So even in object-oriented programming, array is like a most fundamental object. It's basically a list of, but they're a little bit more strongly typed. Anyway, so Python, R, Java, all kind of stuff. You're gonna be definitely dealing with lists of some sort. So list and how you construct the list, how you access the list, right? You construct the list manually. Okay, X is equal to 12 blue boats or whatever, or you can use a constructor like table, array. These are all important, right? Range is a useful one. This is kind of like a way of generating a sequence of number, right? You can use that as an index. This is a good thing to pay attention to. Here I created a range, okay, from 1.2 to 3.5. Yeah, I just picked up something, okay, in step of 6.7. So it goes from 1.2 and add 6.7 until it gets beyond bound. Then it stopped. Okay, it stopped just shy of that. Now you can use this as an index to construct the table. Okay, so range is a very good function to have. Table is a good function to have. Array is a good function to have, right? To be honest with you, I haven't used array as much. Table I use, well, not daily, but I use it a lot. The table is used a lot. The reason I don't use it daily is because a lot of time my list comes from real data, so I don't need to create, right? If I have a table, right, of 10 items, okay, I have to use this table generate. But if I get it from the data, I read it from CSV, and I say assign the CSV data to this table, it automatically has 10 elements. So that's why I don't encounter the table function on a daily basis, because most of the time my list is derived from real data. So when I read the data, it is a list. Okay. So a constructor, maybe I don't use constructor like array or table all that much, but I certainly access them. Okay. And this accessing, right? This thing. Oh, I kind of keep neglecting this because it was kind of obvious to me. If I want X, right? Let's say X has 10 elements, okay? And I want element 5 to element 7. I use, instead of ... I use semicolon twice. I think I've used that and I explained in passing, but sometimes I forgot, right? Now, if I did this, what does this mean? If I say 5 semicolon nothing. Well, use common sense. What do you think it means? It means until you go to the end. Okay. Likewise, if I don't put in the beginning, okay, and I put in the end 7, what do you think it means? It means from 1. Okay. Likewise, what does this mean? It means everything. Okay. By the way, you can use all as well. Sometimes I do that. Now, if it's 2-dimension and you want all of them, but you want the third column, all row third column, what would you do? You would say all. All. That's the first index, right? And I want the third column. That would be that. Okay. Now that doesn't look pretty, so they add the word all to it so that when you read the code, it looks nice. So all row, third column, fourth column, columns all row. Okay. Now, obviously, what's next? Tensor, right? Instead of having two-dimensional, you can have three-dimensional tensor, but you know that's just bracket or bracket or bracket. By the way, what's the most common tensor that you know of? By the way, tensor is a cheapened word. It means a lot of things in physics. Einstein's equation is stated in terms of tensor, but in data science, all tensor means is that it has more than two index. Okay. Two index tensor is a matrix, one index tensor is a vector, and no index tensor is a scalar. That's what it means. Okay. But in physics, it means a lot more. Okay. But anyway, in data science, sometimes they like to use fancy words. So use the word tensor. Well, tensor has 3, 4, 5 different indices, right? So what's the most common tensor that you guys are going to encounter in life? It's going to be a 3-index tensor where the first element is the row position of the pixel, right? And the second element is the column or column row. I don't know which one comes first, right? So the first 2 index is the position of the pixel. What's the third index? What do you guys think it is? The third index refers to the color. Okay, so if I'm talking, I'm just saying this is my picture. Okay, this is my picture. I store this as a data. This is my picture, right? If I do this picture, okay, say 188 and 203 and 2. What do you think this means? Well, I tell you what this means. 188. I may get this back up, but it's 188 row from the top left. So this is go from the top left. 1, 2, 3, 4, 5, 6, 7, 8, 188. Go to the column 293. 1, 2, 3, 4, 5, 6, 293. And what's 2 referring to? What do you think? Blue. Okay. So if this is equal to, if I set this equal to, let's say the color is usually normalized to 1. So if I say this is equal to 0.5, this would be kind of like sort of like a light bluish. Okay, not that light. But if I make it a 0.9, then it's very light. Okay, right? So that's red. Sorry, my bad. Red, green, blue. Number 2 is green. So this is the green. Okay. Why do I say that? Because, and so this, the third one is usually stored in an RGB object. So let me show you what an RGB color look like. Let's say 0.00. What do you think this is? Oops, RGB color. Right? No red, no blue, no green, nothing. So it's all dark. What if it's 100% red, 100% blue, 100% green? What do you think you were going to get? Red, blue, green. Red, RGB, red, green, blue. You're going to get white. Right? So now, what if I get 0.5? 0.5 by what? So this is what I mean by 2 is green. It's this value. Okay. So this is going to be a gray, right? So you want, what color do you want? Anybody? What's your favorite color? Blue. Okay. Red, green, blue. I want blue. I don't want red. So let's do this. That's a blue, right? So that's it. If you want purple, maybe you can add a little bit of, okay. So what I mean is that this is a position, this is a position, this refers to the color position, because every pixel actually has 3 pixels, red, green, and blue. So that's why this thing is now, of course, this 3 index data happens to be the most relevant, I guess, in your lifetime, because you're staring at the screen a lot. But that's not why. Anyway, so we go to this, and this is all the indexing. What I suggest is take this notebook, okay, go to the beginning of the notebook, okay, and go to cell, right? This is what I would do. Go to the cell, delete all output. In fact, we can do it now. Okay. And then go through it line by line, see if it makes sense to you. If it makes sense to you, you understand the mechanism, that's a perfect review. Okay. Anyway, so this is oops, all the way down here. So that's so this is let me just collapse things one by one. Okay, Wolfram Alpha, we don't need to talk about it anymore. This cloud deploy, that's kind of cute, but you don't need this. Okay, output and recall, talked about that. Okay, we talked about this. List and constructor, we talked about that, so let's collapse that. File storage, this is important for you to work on real system. Import, export, that's obviously going to be very important when you do your project, unless your project is from example data, in which case you use a function. Now, before we go on, I just want to introduce this kind of data structure that is second most important. The most important is list. The second most important is association. In Python, it's called dictionary. What it means is that it's a list of reference. So you can think of it as a key and a value. And if you say, I want the key is John, and that looks up John's address. Okay, it doesn't look up John because John is just an index. Okay, so you think of John as a key, the value is his address. Or Jane, okay, Jane's a key, the value is the grade, GPA, or something like that. Okay, so that is association. So association, you can bet your thing is going to be on tested on. That's very important. Okay, now you can use association like this, just use an arrow, right? But a most common way of writing an association is use this kind of funny bracket. I think it's just it's a way of suggesting there's an arrow involved, and I think it looks a lot nicer. Okay, so even though you're actually calling the function association, this is a shorthand for it. In fact, if you go to F1, okay, that's a function, but that's a shorthand, and most people use shorthand. Okay, most people use shorthand. Unfortunately, shorthand is what makes the data, makes the code difficult to read for people who are reading it for the first time, because it doesn't have English meaning to it. Okay, but if you look at professional codes, nobody write association. Everybody just write this. Okay, so that, okay, so association. So this is an association, right? And this is just the previous output. So this is the value, this is the keys, and so blah blah blah. Fine. Now, data set is a little bit more elaborate. If association is analogous to dictionary in Python, data set is analogous to data frame in Python, pandas. I don't know if some of you have had this, so I just thought I'd give it to. It works kind of similar way, except you can do a lot more things like group by and kind of stuff. To be honest with you, a proper data analytics class should actually begin or assume that you have done database programming, elementary database programming. Now, this is something that I'm not quite happy with the setup first, because you guys come to me learning data analytics, which is fine, as long as the data comes prepared to you nice and neat in a table. Okay. And that's why in your project, I asked you to work on example data because it comes to you already nice and neat. In real life, I can bet you, you are going, if your project lasts 100 days, you are going to spend at least 30, maybe up to 70 days with database programming. That is just life. It's like that. Okay. You think of yourself as data scientist. I'm coming, I'm going to build this model from X to Y and cluster analysis and all this and all that. I can guarantee you in your first job and till the day you retire, you have to spend at least 30 up to 70, maybe 80% of the project time, just database programming or some equivalent version, just to get the data in the right form, in the right thing, and just missing data and so forth, selection. So that's why in class like Python, I would say if you learn Python and you go ahead, jump right to scikit-learn or TensorFlow library or Keras, but you haven't gone to play a lot with pandas, you can't really work in real life because pandas is like in-program database programming. Database programming is like you have data set and you kind of filter things you need. You clean things that you don't want. Usually it's done using SQL, but if SQL hasn't done its job, you import it raw, you have to do it in here. And that's where data set or data frame comes in. Okay. So when I say you're going to spend 30% to 70% of your job doing database programming, I don't mean SQL. Okay. You may just have somebody SQL pull the whole chunk and you read it, the whole chunk. And then you do this kind of pandas or database group by, if, and all kind of stuff, select this and that. That's what I mean by database programming. It's not database SQL programming, but it is, unless you've got the good database programming working alongside you. So he or she does this nice and neat to you, give you a table. In which case you will start your job like your project in this class, which is working on curated data, like example data. Okay. So think of example data from Mathematica that I'm going to have you work on as somebody has done the tedious work of cleaning all this, okay, getting rid of zeros and whatnot and stuff. Sometimes it's still zero, but filling in zero is not a big deal. So, right. So this is, I just put here association. I put here data set, and it's just one line in my text in my book. I'm not going to spend a lot of effort on it, but this is going to save your life. This is really how you're going to spend 30% to 70% of any project. Okay. But it's not fun to teach or to learn. But anyway, so this is okay because you don't have this. You have example data. Everything comes nice and neat. So you don't have to work with data set. Right. Now we get to more interesting foundation of what it means to be a function, right? So built-in function, very important. Univariate case, multivariate function. Now with multivariate function, usually there's also such thing as, well, I'll give you a word. You don't have to remember it. It's called operator overloading. In other words, if I say, make me a coffee, okay, make me a coffee, and I don't say anything else, it's like this. Make coffee, okay, this is it. Make me a coffee. But I can also say something like, make coffee 2, 3. That means 3 spoons of sugar. Okay. So maybe I'll have something like, or this, 3 spoons of sugar and 3 teaspoons of milk. Okay. I can use, so what it means is that when you define this function, there is a implicit assignment of what? Sugar. Right? But that has default of whatever, 1. Okay. So you want more sugar, or default is 0 because, diabetic. So I want people to not have sugar. Okay. Milk. Okay. Also, I like black coffee. So So this is how I would define the function. And then I do a whole bunch of things. Okay, many sentences, many steps. The point is, when I call this function, I can call it with no argument or 3 argument for this and so forth. So this is a multivariate function. So univariate function, obviously, it's expecting something. Multivariate, it's expecting the right number of parameters or argument. Okay, there are 2 words in English that I use almost interchangeably. One is argument, one is parameter. Okay, when I use the word argument, what it means is that it's the input to a function. Function takes argument. So right now, my function is make coffee. My argument is 3 and 3. Okay, but you can think of 3 and 3 as what? As the model parameter. I'm modeling concept of coffee. I have in mind this concept of coffee. This concept of coffee has a free parameter associated with number of sugar and number of milk. So if I parameterize it with 3 and 3, the model is a cup of coffee with 3 teaspoons of sugar and 3 teaspoons of milk. Okay, so that's why parameter and argument will be used interchangeably in this context. So think of multivariate. Okay. Now, okay, this thing called pure function. Okay, now it's when you look at it, pure function in explicit form. Nobody really writes this. It's a little bit nerdy. Okay, but it's technically the right. If I put the, again, same with association, if I go to F1, the page called function. Okay, but of course, hello. Okay, function is the full name of it, but nobody writes it. Nobody writes. I need to make quite sensitive now. Nobody writes this. Everybody uses a kind of like a shorthand. Okay. So likewise, nobody uses explicit form. So let me just hide it. But the implicit form is very good. Okay. Implicit form, okay, is used sort of like as a shorthand for a function that does something in one step, in one go. Okay, if you have like a long procedure like making a coffee, boil water, put a strainer, this is so many steps, you would probably name it a function. You would use a name function. But for something quickly, like take the minimization, take the minimum of the or scale the series of number to the median plus standard deviation. I don't know, something like in one go. Usually you would use this kind of pure function. It's much quicker and it's obvious, right? Because if you write a name function, if I want to know what it does, I have to go look at it. Hopefully there's a documentation and so forth. But this, obviously, what I want to do, I want to take the first guy, add it to the exponential of the second guy. It's a monkey see, monkey do thing, right? So if in the exam I say, give me a monkey see, monkey do version of, and I write a mathematical expression, you should be able to write this. Okay. And it just say, this is the first guy, this is the second guy. Now, why does this not have number 1, number 2, number 3? Because it takes just one guy. But then you apply it to this. Now it happens to work because this function works. This is just one thing, right? Take this thing, divide by its length. Now, it happens to be with the understanding that you just go element by element. So it does work. Fine. So this is a monkey see, monkey do kind of thing. Right. So this is the same thing. Again, I just want to write down it's true, but it's not exciting. Now, user-defined function. Now, this is where you do most of your programming. Okay. So you can think of this as, oh, by the way, remember I told you about this data cleansing, this database kind of cleaning bit going through the whole series. you use this a lot because sometimes you just want to do something simple, like, move it from Celsius to Fahrenheit or something like that, right? What do you do when you do move from Celsius to Fahrenheit? You multiply by 1.8 and then you add 32. Now, would I write a function that say convert from Celsius to Fahrenheit? That's a little bit wordy, right? So all I do is just this. So say, well, how about this? How about I just take whatever the temperature it is, I multiply by 1.8, 1.8, and add 32. Make this a function, and then I apply to what's this room temperature? It's 30, right? 30, 25, 26, 4. It's 76 degrees in Fahrenheit, right? 76 degrees Fahrenheit. Now, if I want to do a few at once, then remember this thing that's useful, apply. So if I apply to 25, 24, comma, 27, 28, 29, 30. Yeah. So it applies one by one. So 24 Celsius becomes 75 degrees Fahrenheit, 28 becomes this, and this, and this. Okay. So it's monkey see, monkey do. And so if you have like a data that comes in Celsius, you want to work on it Fahrenheit, don't write a big function somewhere else, and just do it one liner. Okay. So this is very useful, very useful. Now, if you want to do something more important, yeah, definitely you have to do this. So I define this function again, simple function, but it could be a lot more simpler, a more difficult function. For example, and then just something y equal to this, and then that is equal to y squared, whatever, okay, and then return that or whatever. Okay, you can do a lot more complicated thing. You just put this separator. By the way, don't do this. Yeah, write it like this. If you're going to do multiple instruction, so do this, do that, do this, do that, blah blah blah. Okay. But this is already, since this has only one instruction, I just put it that way. Okay. But obviously, yeah, if you go through the trouble of define this function, chances are it's not going to be something that's written in one line. It's going to be something that takes 7 lines or whatever. Okay. So same thing, function, the same thing. This is just relating pure function to function. Right. Now, this is the construction that I want you to be able to replicate, definitely, in exam. This is a function that has an outside parameter, outside argument, but it has a local variable. The reason I do this is because what? This is something I give from outside when I call it. This is something I define locally, right? Once I execute this, what happened to n? Nothing. N is not assigned elsewhere. So this is this module. This is what I mean by important thing. Okay. So this instruction where, my function outside or external argument, then is equal to module. Okay. And module has two parts, right? Has the action and has the local variable, okay? And do something, local variable equal to outside argument plus 3, okay? Right. Now, occasionally you will notice from my own code that if it's something simple, sometimes I write it in the initialization. In other words, I just do this. Okay, I can do that, but that's not being sloppy. That's just being short. Okay, but to write everything out, declare first. I want to have a local variable that doesn't exist out elsewhere. I do something to it, and maybe I do something else. Maybe I have, maybe I want to return both. So I say return both outside argument and local variable, something like that. Okay, so let's do this. So if I define this function, and I say I give 1,000, what do you think I'm gonna get? Well, it's gonna get this, right? Because the original is here and the local variable is here. But do I know what this is? No, it's blue. Okay. So this construction is, again, this is one of those things where from my experience, I specify the most useful stuff. In fact, if you say pick up a book in programming, module is not something that they introduce in the introductory class, but because variable scoping is a little bit more advanced, but I insist that you know this because it's so useful. It's so useful. It's a little bit like I don't know, icon system. Okay, it's not ubiquitous. It's not taught everywhere all the time. It's a little bit advanced, but trust me, it's so useful. Might as well learn it today. Okay, so this kind of function, this kind of module, this kind of thing is very useful. The definition with local variable is very useful. Map, this is also a thing. This is a shorthand. Shorthand of this is this. It means apply this to this, this, this. Okay, apply just mean apply this to that. So that's not very interesting. I don't use this a lot. I use this a lot. Replace all, that's also used. So thread, I haven't mentioned this, but thread sort of like it's a little bit like transpose, where you reverse the order of X and Y. So from X to Y becomes from Y to X and so forth. But nah, a little bit so. I'll give you just an anecdote. Some of this thing, okay. I don't know how it came about, but transpose is a mathematical manipulation, transpose matrix. You can think of thread as a sort of like a non-mathematical operation that feels like a mathematical operation. And it's very useful in life. So thread is one of those things. I put it down here because it's so useful. Okay. Another thing is called inner. I'm not going to tell you what it does, but it's a little bit like dot product. Dot product is a mathematical operation. Inner is sort of like computational operation that feels a little bit like inner product. It's so useful in life. I use it in my project. For example, if I want to say, yeah, if I want to trace your parentage, okay? Bob is the father of Jane and Joan. Okay, so there's a matrix of parenthood. If I want to create a matrix of sisterhood, I can use manipulation, inner manipulation on the original matrix, and I can say Jane points to Joan, Joan points to Jane, or something like that. Okay, I just want to give you an anecdote. But now, this analytical functionality, I want you to really appreciate. Just go through them and see how this is one of those things where up to now, yeah, Python is not a high level language, but it does pretty much what you ask it to do. So even though you can write one line in Mathematica, it may take you 5 lines in Python, you can still do it. You can still do it. Here, what's in here cannot do it because it doesn't have an understanding of an symbolic interpretation. It doesn't know what limit is. It doesn't know what infinity is. It doesn't understand anything beside data structure. So here, I just put here, technically, it's not really fundamental to data science or data analytics, but this is where, you cannot do something like this equivalently in R or JavaScript, and depends on how you need it. In data science, you probably don't need it, but I came from the world of financial engineering and economics. There's a lot of times where you need to understand analytical relationship between X and Y. Okay, it's not X and Y comes in a data and I want to learn a machine learning model to predict Y from X. No, no, no. X and Y are related mathematically. Okay, and I want to know how fast Y changes when X changes. That's analytical derivative, not numerical. Okay, so in financial engineering, in economics, I'm from the Bank of Thailand. This is something that, Python would not have served me at all. Okay. And I did do some work at Bank of Thailand that required very powerful analytical thing that, as far as I know, at that time, Mathematica was the only platform that could give me. Okay, it was about Coppola modeling. I was trying to model a relationship between two variables that's not. Talk about it. That's beyond this class. But Coppola modeling, I actually created my own Coppola, and I had to use Mathematica to find the normalization. Okay, so this is okay. This is numerical computation in a sense that so something like this. Yeah, MATLAB, Python can do maybe even faster because they're optimized for numerical, I think. So if your job is engineering where you take numerical measurements and you have to sort of like do numerical calculation on numerical measurements in engineering, then chances are, yeah, you can use Mathematica, you can use MATLAB, and my guess is for dedicated application, MATLAB will probably be faster. That's my guess because engineers use that to make a living. So visualization. Okay, so these are things that I put as a help file, but these are definitely things that you are going to be using. Now, forget about the machine learning and this for a while. This is something that we'll talk about it later, right? But certainly visualization and manipulate. Okay, so you can bet you are anything that I'm going to ask you to write something that has manipulation. Right, manipulate. Okay, manipulate color, manipulate length, and so forth. So interactive visualization go through that. Okay. So I'm gonna finish with this, and then we'll take a quick break. Again, plot. So this is visualizing function. Okay, that's interesting. This is kind of like visualizing. So you can click on any of this. Okay, and it's gonna give you something to look at. But this is kind of mathematical object, so chances are you're not going to be playing with that a lot, but I put it here for completeness. So it has, built-in things like, you guys know what this is? It's a donut, right? Donut. You can actually have a planet that looks like a donut, and the animals that live on top of that would be two-dimensional like us. Okay, so except topography will be different, but play with all kind of stuff. So now this is more interesting. Visualizing data point. That's where you guys come in. Okay, so again, old faithful, go through this line by line, list plot, right? Now I added something here for visualizing time series that I think I didn't use in your class, but might as well go through that. So this is financial data. It's a little bit like example data, but it's more finance. So I happen to I was working on something. I thought I'll stick it in here. So financial data is like, well, we're going to be using it as an example in supervised learning. Financial data would be like looking up stock price or something. Okay, so here it actually access. I think you need internet because, for example, okay, watch this. If I do a double quote, right, double quote, and I put in something like NASDAQ. Now, for some reason, it's not auto-suggesting. But if I, oh yeah, maybe the older version. In newer version that I have in my that you should have and I have on my machine. When you type in partially, it's going to make a suggestion. It should make a suggestion. I don't know what. Yeah. So it's going to list all kind of stock variable that you have. So NASDAQ. So if you don't know anything, put star. All the NASDAQ listing. I'm not sure if stock. Yeah. So Google, Apple, all sort of stuff is in here. Anyway, so it has all these properties, right? It has all these property, close price. Some of you who are more into financial engineering or even econometrics more likely to use this than others. Example, well, it's close to us, I guess, is dollar baht, right? Now you can say, okay, financial data, Thai baht from, I don't know, I just put example here, 20th of February and so forth, and okay. So some of this would be accessing. This is kind of like a obvious. You know the symmetry, right? This is a euro in terms of dollar, dollar in terms of euro, and so forth. Okay. So you can visualize data point. You can visualize time series. You can actually have date object and so forth. So there's a lot. This one I haven't covered. Visualize. Okay, we talk about this country, right? Thailand, whatever, Brazil, Ukraine. I just thought these are the most colorful flags I can think of off the top of my head, right? So very colorful, very nice. Then I can look at right. So these are all the visualization. Now, what I'm going to tell you is during the exam, okay? Yeah, I want you to know how to use things that you have seen. But what if I tell you something you haven't seen? I want you to use maybe a different kind of plot, some kind of waterfall plot. I don't know. Okay. Now all those are going to be in here. Okay. Where's the visualization? There's a visualization. Oh yeah, I haven't given you. Well, it's this reference thing. If you go to the top, okay, let's get this one. Sorry. Let's go to here. Okay. So this is financial data, right? Now, if you go all the way, just all the way up to the reference, okay. Now, this is a master menu. During exam, you will be able to go to this for help. And let's say I ask you to say, okay, this is a visualization, right? And you've done list plot, but you haven't done, I don't know, stack list plot. Okay. What if I want you to say, okay, bring your data, the data that you want to work with for your project, right? Do a list plot. Obviously, you've done that, right? But maybe I want you to try something else. Well, you don't know exactly how it's going to look like or the parameter, you know, how to orient and all this. Well, this is in here, right? This is in here. Heat map matrix, all this is stuff. So just because you haven't been taught doesn't mean you can't find it. All right. So yeah, bar chart. We haven't, for some reason, we haven't talked about bar chart, I think, but bar chart is so ubiquitous. You should be able to use it. Okay. Quantile plot, gate. So some of this. So I would be very tempted to ask you to not just use the thing that you've seen, but use something else. Okay. Be creative. Okay. So that's a visualization thing. And well, okay, let me finish with this. Interactive control. So manipulate is very important, right? Manipulate. This is the whole thing about having this kind of buttons, right? This is kind of button. So manipulate is a big thing. And there's like a huge tutorial in there. Shows you how to, you know, put this on the right, put this on the left, and have different kind of button to make it look nice, all kind of things. Okay. So those are not all that critical. But again, think about it, guys. Presentation is not everything, but it certainly is a big part of making the first impression. So if you're going to make your invention or idea come across, right, and you show something and it doesn't have enough, let's say you show something in 2D and your client would like to see it in 3D to get a better appreciation of the model, right? So think of, you know, I'm showing this, right? Yeah, I can certainly say, okay, front view, top view, bottom view, okay? But if I allow this manipulate to say, okay, I have an option to view in 3 dimensions. I have an option to view in wireframe. You know what a wireframe is, right? It's like, it looks like, well, it's a wireframe. Okay, so you can have all this, and maybe your client is more responsive to 3D visualization than 2D. Okay, why would you want to show something that has no option of display? Okay, so again, it sounds like we're being fussy about something that's not substantial. It can be substantial. Okay, and don't underestimate the importance of communicating your idea to your project owner, to your client, to your whatever. It is important. It is important. I pay a lot of, in the beginning of my career, I kind of thought this is kind of like marketing gimmicks and stuff, but it's more than that. It's more than that, because we're not selling candies. We're selling technical stuff. So technical stuff has to be bought by people who understand technical concept. And if they're not technical people, it's our job to communicate the idea to them. So visualization, 2D, 3D, time series, all kind of stuff, I no longer think it's gimmick. I think it's critical to my project, all my project, to have this visualization as part of the deliverables. Okay, and I would suggest the same. I would suggest the same. So this manipulate is very powerful. And even in a project where the ultimate handover is written in Python, because you know it has to work with the back end of the company, whatever. When I present the function or the algorithm or the capability, I still use mathematical interactive visualization. Okay, and then once I show them, I say, well, in a production version, you won't have this. You have like a static version, but that static version works with Python code that works with your back end and so forth. But this is how the concept is. So I use this to communicate, and it's very important. Okay, so let's take a 5 minutes break. Yeah, and 5 minutes break, and then we'll come back. Then we'll start with, I would just briefly mention probabilistic modeling, but definitely supervised learning. I'm going to spend a big chunk of this reviewing and going through the nitty-gritty of unsupervised learning. Okay, Kap?